Hello. Today we're doing perpendicular bisector constructions and perpendiculars. So perpendiculars from points that are either on a line or not on a line, but you're not looking for the bisector. But you want to start with the bisector. And the reason is it's needed for the other types of perpendiculars. Constructions are a really important construct for students, important for you to do because it really emphasizes how circles are so important. That's why we use a compass, because a circle is the only construct where you absolutely know you have congruent segments, because from the center to the outside of any circle is a radius, and all the radii in one circle are congruent to each other. So that's why we use circles, because we automatically have congruent segments. And perpendiculars need congruent distances, which come from circles, because that's a property of perpendicular. So we're going to do a perpendicular first. So you have to have a segment. You can't have a bisector of a line or a ray because they're infinite in at least one direction. So I'm going to make a segment, and I'll make it too big so we can see it. And I want the bisector of this. Now students should have an understanding of what a bisector is and what its properties are, what a perpendicular bisector is, what its properties are. It cuts through the middle, it forms 90-degree angles, and more importantly, it's equal distance. Every point on it is equal distance from the endpoints of that segment. So wherever a point is on the perpendicular, it will have the same distance A to that point as B to that point. That is important. That's what we're looking for. So I need to basically make congruent circles. Well, how do I make congruent circles? I need to make sure I have the radii the same. The radius has to be the same. So when you have a segment, a quick way to make a circle is to use one endpoint as the center and the other as the length of the radius. You don't have to do that. You could obviously make a circle. Remember, we're trying to get the bisector, so we want to go past the halfway point. So you could just have two circles that intersect, as long as their radius is larger than half of this segment. But I find, especially when working with students, we just want to use this radius. We want two circles, one at the center A, one at the center B, that have the same radius, and that radius is going to be the length of this segment. And I know if I use that same length, open my compass to the same distance between A and B, that my two circles are congruent. So I'm going to get the circle tool, and I'm going to do that. So I'm going to start one at A, and open it to the radius of B, and then I'm going to get the second one and have the center at B and open it to the radius of A. So they have the same radius. AB is congruent to BA, and so therefore I know that these circles are congruent, and any radius in them therefore is congruent. If I have a radius in circle B, I know it has to be congruent to all the radii in circle A. That's important. So if you notice, I have these circles intersect in 2 points. So let's do a couple things. We're going to change the color so we can see them, and then let's construct. That's not what I wanted to do. I didn't mean to change the color of the circles, but let's construct the intersections. So there's my intersections, okay? So these intersect, and I'll show you this really quickly. I'm going to just get some segments right here to talk about what's actually happening here. If I were to draw the radii from circle B, from B to C, and from B to D, those are just two radii in my circle B. They are congruent to AB because they're in the same circle, right? So I know that BD is congruent to AB, which is congruent to BC. They're all radius in the same circle. But remember, this circle with the center B is congruent to the circle with the center A. Therefore, if I make the radii AD and the radii AC, they are also congruent to this AB and their radius. All these lengths, all these distances are congruent. I could even mark it if it helps me understand what's going on. I could mark, and just to show that all the distances. Well, why does that actually matter? And I'm going into a little more depth than maybe you might with students, but why does it matter that these are congruent? Well, if you look at these 2 points, C and D, since the DA distance is the same as the DB distance, that means D is equal distant from the endpoints of A and B of that original segment. Same thing here. C is equal distant from B and A. And that is a property of a perpendicular bisector. If I were to connect C and D with a straight line, they would be on this bisector because the definition, one of the properties of a perpendicular bisector is that all the points on it are equal distance from the endpoints of the segment that it's bisecting. So right away, I have found my perpendicular bisector. All I have to do at this point is now connect with a line or straight edge those 2 points, and I have, in fact, let's change the color here so it stands out a bit more. I now have my perpendicular bisector because it has all the properties of a perpendicular bisector. So that's the construction of a perpendicular bisector. You want to make sure you go through that first because it's really explaining how do we know that's a perpendicular bisector. Now I want to show you how we're going to use that understanding of perpendicular bisector and the fact that I need a segment, 2 endpoints, to be able to construct that bisector. I'm going to come back to this construction several times for the other 2. So let's go into the another geometry sticky, and this time I want to do a line just to show you that you don't always have to have a segment. You can have a line or a ray. So let's just make a line, make it go a slightly different way here. All right, so there's a line and I have a point not on it. How do I construct a perpendicular from this point to this line? Notice it's not a bisector because a line can't have a bisector. So how do I do that? Well, I know that I can make a perpendicular. I know how to do a perpendicular bisector. If I had a segment, I could just do the endpoints and use that segment as the radii of 2 circles. Well, I don't have a segment here, but I could make one. So I'm going to change the color here just so we are able to distinguish. I'm going to make a circle from center C. Why am I using a circle? Because I know that all the radii in it are equal distant, right? So I'm going to use a circle. I'm going to use C as the center, and I'm going to make my circle open up so that it has at least 2 points, because what am I looking for? 2 endpoints of a segment intersecting with that line I'm trying to be perpendicular to. So it intersects, and so we're going to select that, and we're going to construct the intersections. So it intersects at E and F, right? In fact, we don't really need to see that, so let's hide that point. Well, let's even do this. Let's get our segment tool so you can actually see this. All I've done is created a segment that is on my original line. And that's all lines are, a set of points that are collinear and all connected, right? Infinite points. So I just have chosen 2 that happen to be, you know, these intersections of my circle and my line, but this is just a segment that's still part of my line, but I'm going to use just this little piece of the line that I've now kind of highlighted to now go through the exact same steps I did up here so that I can create a perpendicular. I'm going to, in theory, create a perpendicular bisector to this small segment I created, but it will still be a perpendicular to the entire line. So what did we do before? Let's change our colors again just so we are standing out. We made a circle that started with E, one of the endpoints of my segment, and opened up with a radius to the other. And then we did the same thing here. And now we have 2 intersecting points. So I'm just following the intersection I did up above. Now, what do I know? These 2 points are the intersections, and I'm going to collect them, and C is going to lie on this, and I know this because C was created by doing, and if we need to see it, let's do it real quick so we can see it. C was created by making 2 points equidistant from the endpoints, right? These 2 points are the same distance. These 2 points are the same distance. And these 2 points are the same distance to H. So all 3 of these points, C, G, and H, lie on the perpendicular bisector because they are equal distant from the 2 endpoints. And so I know that this must be, the line must contain this. So if I go get my line tool, and let's get my line, my straight edge, if I had a protractor and a straight edge, and connect, I could do all the way up to C, but now I have a perpendicular, and let's make it not be dotted. This is now perpendicular to my original line. Now, I have a lot of stuff going on here, right? Nice thing about geometry software is you can actually select stuff that you don't want to see anymore and hide it. So we can do that real quick. And just hide that. And so, oops, I hid the wrong thing. So let's undo what I just did. I should have hidden my line. I hid my line there. But it makes it perpendicular. Let's try another one. So let's quickly do one. And it's the same. You'll see it's the same process. It's that understanding that a perpendicular bisector has points equal distant from the endpoints of a segment. So we're basically creating a segment on the object we're given so that I can make a perpendicular bisector. So let's say this time we have a ray. I just want to show you differences. So here's a ray, and this time, let's say we have a point. Now let's change the color of the point. Let's say we have a point that's on the line somewhere. It doesn't matter where it is. It just has to be somewhere on the line, right? It doesn't really matter where it is. Let's make it over here just so it looks different. All right, so here's this point, and I want a perpendicular through this point C, perpendicular to the ray. Okay, so what am I needing? I need 2 points to make a segment, right? So I'm going to use my circle again because I want them to be the same distance, and I'm going to use that point as the center of that circle. And it doesn't, again, matter how big or small I make this circle. I'm going to make it kind of small here. And it's intersecting already, so let's make sure we have both intersections. So what do I know about these intersections? I know that E and F, let's hide that. Sorry, I got too many points going on here. Let's hide that. I know that E and F are equal distant from C because they are points on the circle where C is the center, so these must both be radii. And I could, again, I don't have to do this step, but I like to just to show students, this segment right here of EF is now a segment that I want to bisect. Well, we already know that this is being bisected right here, right? The center is bisecting because they're lying on a line, so they must be a diameter. Lots of things I could go through, but I'm basically going to go back to that original construction. I want to use these 2 endpoints of my little segment that happens to lie on my ray as the centers of circles that are congruent. So again, I'm going to change the color here. So I'm going to make 2 circles. So one E with a radius of F and one center F radius of E. So now these are 2 congruent circles. That, again, we're just repeating the same construction. Since they're congruent circles, all the radii are congruent. I'm going to make the intersections, and I know that these intersections are equal distant from the endpoints of this little segment that's part of it, and so I know that if I get my line tool, straight edge tool, and connect these, I have made a perpendicular bisector to this small segment EF, but if I'm looking at the whole ray, I know that now C is perpendicular to this line through C. There is this green perpendicular line going through the ray AB because of how I constructed it. And it's all based on that idea of circles with congruent radius, equidistant from the endpoints by using congruent circles. All of that is connected.